So how to calculate the polynomial represented by LFSR? This is the way. You will start from here C0, C1, C2, C3, C4. And the number of flip-flops, this is the exponent degree. So here this one is your MSB. This is your MSB. And this C0 is your LSB of your polynomial. So LSB is starting with x raised to power 0. So 1 plus C0x means 0. C0x is square, this is C1, this is C2. Both of these are 0, C3 and C4. So C3, C4 are 1. So that's why C3 x cube plus C4 x raised to power 4. That's how you have calculated the polynomial. ओके दिस इज द वे हाउ यू विल बी कैलकुलेटिंग द पोलिनोमियल. ये किसी को समझ में नहीं आया, यू मे आस्क इट अगेन. यस प्लीज. आ गया सभी को समझ में? ओके सो now compression techniques we were using. So in compression techniques, these were different techniques. We have discussed ones count. Here we have to count the number of ones in the fault-free circuit and in with the fault circuit. So if the number of ones are not same, we will say okay, the error is there. So this compresses your signature. Transition count, how many transitions are there? Transitions can be counted by XOR gates. So we are using XOR gate with the delay, so that the delay means this is how you are going to provide the delay. So delay means the ith bit and I minus 1th bit. Both of these are XORed. It means you can see whether both of these bits were same or not. So in this fashion you can count the transition. Parity check. Parity means even parity or odd parity. So it is going to give one number. Even parity means 0, odd parity means 1. So depending on that number, you can count whether it was parity was same or not. So in this fashion, you can count, you can find out your errors, right? Your faults you can find out. Now next two are remaining: syndrome checking and signature analysis. So practical compression techniques, these are easy to implement, part of BIST logic. Although these are not foolproof, but yes, partially this can detect the fault. Small performance degradation, that means it is not foolproof. High degree of compaction, so that a smaller amount of memory is consumed. No or small aliasing errors are there. And why are the aliasing problems? We have already done that, so I'm not repeating that again. These all we have completed. So syndrome checking was left. In the syndrome checking, what we have to do, we have to apply the random test patterns. This is how we'll be applying the random test patterns to the CUT. You have to count the probability of one, how much probability of ones is there. The property is similar to that of ones count. So this property is similar to the ones count. Probability of finding ones means what? Let's say there is a 10-bit number. It is somewhat like this and 1. So here the number of ones are 2, 2, 2, 7. So what is the probability of finding ones? It is 7 by 10. And the number of ones were also 7. So in this fashion, this is similar to the ones count. Okay, so what you have to do, you have to check the syndrome, and from here you have to take the counter, and then you will be comparing both, and this is going to give you the syndrome analysis, right? So from this you can find out whether this was having error or not. Now next one is the important one, and this is the signature analysis. This is LFSR based signature analysis. So in this signature analysis example is given. In this example, internal type LFSR has been taken. So the polynomial decided by this will be given in this fashion. This is C0 is 1, C1 is 0, C2 is 1, C3 is 0, C4 is 1, C5 is 1. So actually, if you want to represent in terms of bits, so it will be represented like this. If you want to represent it in terms of polynomial, this is your MSB as I told, this is your LSB. So MSB means 0, 1, 2, 3, 4, 5. So x raised to power 5 plus x raised to power 4 plus x raised to power 2 plus 1. This is the polynomial. This is what px is. समझ में आया? How this polynomial is created from the internal type LFSR. ये समझ में आया कि नहीं आया? Yes?
Yes, ma'am.
Priyanshu, syndrome means the probability of having ones in the randomly generated test pattern. So as I have given the example of 10 bits, here the number of ones were 7. So the probability of being ones is 7 by 10. So the same number of ones will be compared from taken through the counter from the original random test pattern generated, and then these two will be compared, right? And that's what the syndrome is. Okay? Yes. Shall we proceed for signature analysis? So for signature analysis, we will be finding out what the polynomial is, and then the generator polynomial. So generator
मैम
polynomial, हाँ बोलो. Somebody wants to say something?
मैम इसका पीएक्स का एक बार एक्सप्लेन करना वापस
पीएक्स का
एक्सप्रेशन।
एक्सप्लेन करना है, ओके. चलिए पीएक्स का एक बार वापस से मैं बता देती हूँ. Look, what we have to do wherever we see this is connected, that particular bit becomes 1. If you can recall, this was like C0, then if the connection is there through this, then this becomes C1, otherwise 0. So this is your C1, this is your C2, C3, C4, C5. And how would you represent it? Summation of Ci's x raised to power I is equal to 0 to n. This is what your polynomial is, px. Okay, so we have used this formula, and in order to use this formula, what you have to do, you have to just collect the number of CIs. What will be the CIs? So this is MSB I told. So in terms of CIs or in terms of bits, I can write it in this way. ऐसे लिख सकते हैं इसको. Yes, Raj.
यस
Okay. Now you have to use the simple fundamental 2 raised to power 0, 2 raised to power 1, 2, 3 up to 2 raised to power n. This is how you use to represent in terms of bits, right? Bits ko karna hai. But since this is a polynomial, so we will be using x raised to power instead of 2 raised to power. So if you are using x raised to power, so what it will be? X raised to power 0, this is x raised to power 0, this is x raised to power 2, then this is x raised to power 4, x raised to power 5, because x raised to power 1 and 3 are having 0 multiplier, so those are automatically 0. Now you will be summing up all, so you will be getting this polynomial p is equal to x power 5 plus x power 4 plus x power 2 plus 1, and this is what it is, px. Yes, Raj, got it?
यस मैम
Okay. Now let us have the generator polynomial, which is represented by gx. So in the signature analysis, you will be having two polynomials. One is the polynomial px, which is given by the LFSR, and another one is the generator polynomial, which is gx, which is represented by the set of inputs. So look at the set of inputs. You are having this input test pattern. This is your input set. Okay, these 8 bits you need to put in. Okay, so here the MSB is 1. This is the MSB. So MSB 1, what will be the multiplier for MSB? 2 raised to power 7, or here x raised to power 7. These are 8 bits. So the MSB is 2 raised to power 7 plus the next one 2 raised to power 6, 2 raised to power 5, 2 raised to power 4, 2 raised to power 3's multiplier is 0, so we will not take it. 2 raised to power, sorry, x raised to power 2, x and x raised to power 0. So in this fashion we'll be having this generator polynomial. समझ में आया? Yes? Got it? बोलो भाई, बोलो. Okay. So now this is the generator polynomial. These are the register contents. Initially, all the register contents are zeros. Okay, all the register contents are zeros. So these are zeros. Then you will keep on pressing these inputs. So MSB will be taken first. That's how this has been rearranged. इसको देखिए rearrange किया गया है because MSB सबसे पहले जाएगा. Right? MSB is this one. So this has been uh, rearranged like LSB is coming at first and MSB is coming at last. Okay, so after rearranging, in every clock cycle one of the input will get shifted to the uh, linear feedback shift register, and the newly calculated states will be given to the next one. So look at this, these were the contents of register. Now what you will be having, 0 or 0. See, this is 0 you are having here. This was 0, right? And then this is also 0, 0. The content of this was also 0. So 0 XOR 0, you will be having 0 here. This 0 got shifted over here, so this is also 0. You got 0 here and 0 from here, so again you are having this 0. This 0 got shifted over here, and the 1 from this will get entry to this. So in this fashion 1 4 times 0 will be the next state. ये समझ में आ गया कि नहीं आया? Yes. This is simple LFSR calculations. After that you will be getting the outputs. So the first output will be visible after, see, in the first clock cycle the first entry is going here, second clock cycle the first entry is here, third clock cycle it is here, fourth clock cycle here, fifth clock cycle here, sixth clock cycle you can see at the output. So it means in the sixth clock cycle you will be getting your first bit output. Okay, so by that time you have to calculate all these things. So in order to calculate all this I am just using a rough paper so that I can make you all these understand. So gx is somewhat like this. This is your gx. Gx was 1 1 1 1 0 1 0 1. So when you are taking the time or the clock cycle 0, and gx you have to invert this because MSB will be taking first. So 1 1 1 1 0 1 0 1. Now your polynomial is like this: px is equal to 1 plus x square plus x raised to power 4 plus x raised to power 5. Okay, so internal contents of the register contents will be like this. In the first clock cycle all of these are zeros. So in order to calculate, I am just reproducing the actual structure of the LFSR so that we can recalculate, I mean we can easily update the values. So look at this, you are having OR gate here, OR gate here, and OR gate at the input. So 3 OR gates are there. So this is one OR gate at the output, 1 2, and this is the 3. So third one is having the input value XORing with the last value. and this one is having the input plus the content of this. This is just a shifting, and this is having o-ring of content of this and the last value, and this is just shifting. Okay, so first all of these are containing 0 0 0 0. Okay, so now look at this, all these are 0, all these XORs are having one input here. Yes, so whatever the another content, the same content will be at the output. So here this was 0, so it means 0 is getting shifted, so that's how you will be getting 0 here. समझ में आया? See, initially you are having all zeros, so contents of all registers were zeros, all flip flops were zeros. अब आपको नया वैल्यू कैलकुलेट करना है, so for new value this zero is there because this d0 was 0, so सबका ये 0 हो गया, and new content is 1 here, so this 1 is pushed here. Now this is getting shifted to this, so this 0 is getting shifted over here. This 0 is XOR with this 0, so this is again 0. This 0 is getting shifted, so this is also 0. This 0 is XORed with this, so this is also 0. So this is the new content of this. And what about this? This has been moved, so now you are having this content from input data set, and the clock is the next one. Next is the clock. What is the output? Output is not here. After sixth cycle you will be having the output, so don't worry about the output because the first output will be because of this. So I will keep on highlighting this bit because this is the bit we need to track for the output. Okay, now next we have to calculate again. So look at this, this is 0 and the content of this is 0. So new content of this is also going to be 0. This is pushed to this, so this is also 0. This is 0 and this is also 0, so this content is also 0. This is pushed forward, so this is 1. And this one is pushed here, so this is also 1. So 1 1 triple 0 is the next output. Sorry, next content of registers. And now the input set is this. So this is the input set, this one is out, and this is the entry. So once it is out, you will be saying that this is the first output. Okay, so now next one, the XOR of this and this, इनका XOR क्या आएगा? 0. So the content of this is 0. Shifting of this over here, that is 0. So you are getting 0 over here. XOR of this and this, इन दोनों का XOR क्या आया? 1. So you are getting 1 over here. एक बार इसको चेक कर लेते हैं. So look at this, 0 and XOR of this, you are getting 0. So this is how you'll be having 0. This is getting shifted, so 0. And now this 1 XOR with this, so you are getting 1 over here. यहाँ पर आपका 1 आ जाएगा. So you are getting 1 over here. ठीक है, ये यहाँ से 1 आ गया. Now this one is getting shifted, so this one is getting shifted. And now another input from here plus XOR of this. How much you will be getting? 0 XOR with 1, you are getting 1 over here. So 11100 is your input set now. And what you will be having, because this has been shifted, so you are having this data set now. Okay. So now let's calculate the next one. So in the next one also, this is 0, 0 XORed with this 0. So again, the content of this is 0. This 1 is getting shifted over here, so you are having 1 here. So you will be having 1, 0. And now the content of the third flip flop will be from this and XOR of this. So XOR of this, because this was 0, so 0 and 1, you will be having 1. The content of third is also 1. Okay. Second is the shifting of the first one. And first one is the this XOR with this. So again, you will be having 1. So the contents of register at the end of second, third, and fourth cycle, you will be having these. And what will be the next set of inputs? This will be the next set of inputs. समझ में आ रहा है सभी को?
Yes, ma'am.
Yes, screen might be delaying बिकॉज वॉइस हमारा डेटा थोड़ा जल्दी पहुंच जाता है ये एक्स्ट्रास और स्क्रीन थोड़ा डिले से पहुंचता है बट व्हाट यू हैव टू डू जस्ट टेक पेपर एंड पेन और जो मैं लिख रही हूँ उसको साथ साथ लिख कर देखो जिससे आपको इजीली समझ में आ जाएगा ओके yeah so now let's calculate the next one the fifth cycle we need to calculate so this was the bit to be identified here so after this bit is at the outside we'll be having the output so now the content of this so the content of this will be this XOR with this so this is 1 we'll be having 1 content of this is the shifting of this so you will be having 1 here content of this is this XOR with this so again you'll be having 1 here content of this one is shifting of this so again 1 and this is 0 because this is getting XORed with this and then you are having this at the first entry so this is 0 समझ में आ गया ये फिफ्थ एंट्री yes or no so now you are left with
Can you please
this
repeat it?
entry at the कुछ बोल रहे हो
मैम फिफ्थ वाले एक
सुकृति
बार वापस.
सॉरी हेलो
मैम कैन यू एक्सप्लेन द फिफ्थ वन वंस अगेन?
हाँ फिफ्थ वन एक बार मैं वापस से एक्सप्लेन कर देती हूँ जस्ट वेट अ मिनट So tell me in the fourth cycle, what is the content of D0? D0 का content क्या है?
0.
This is D0, right? This is D0, so this is 0. And all others are 1, 1 and entry is also 0. ठीक है? तो एक बार ये हम लोग LFSR में डाल लेते हैं and then we will be discussing. So I'm removing all this. Yeah. So this content was 0 and all these were 1, 1, 1, 1. Now what you have to do, you have to XOR with this content in order to update the new. So this is 0. ये देखिए this 0 has been circulated to all. यहाँ तक ये 0 चला गया. Here the entry is 0. So सबसे पहले चलिए इसको कैलकुलेट कीजिए. 0 XOR 0 क्या आया?
0.
Yes or no? Right. 1 is getting pushed to this. So इसका content क्या बन गया?
1.
1. This was having 1. This 1 is XORed with this is D0, right? So D0 के 0 के साथ this 1 is getting XORed. So what will be the content of this?
1.
1 XOR 0 is 1. This 1 is getting pushed here, so this is also 1. This is 1 and this is XORed with 0. So how much you will be getting over here?
1.
1 XOR 0 is 1, right? So this is how we obtain yes yes or no सुकृति?
Yes, ma'am. Got it.
ओके, अब हमें अगले साइकिल का करना है, तो अगले साइकिल में व्हाट इज द इनपुट? इनपुट इज 1। ये देखिए, दिस इनपुट वी हैव टेकन, नाउ द इनपुट इज 1, सो विल बी हैविंग द इनपुट 1, सो हियर द इनपुट इज 1। चलिए इसको कैलकुलेट करते हैं। Yeah, so how you will be calculating? These are the contents. So in contents ko I am writing here 1 1 1 1 1 and 0. These are the contents. So this 1 means d0 is 1, so this is going here, here and here. Let us calculate the first from d4. We will be calculating. So this 1 XOR with 1, क्या आएगा यहाँ पर? This content of this
0.
1 x, this 0 is getting shifted over here, so this is 0. This is 1 and this is getting XOR with 1, क्या आ जाएगा? 0,
0.
right?
Yes, ma'am.
So this is the content of the flip flop getting shifted over here, so you are getting 1 here. This 1 is getting over here. आ गया समझ में?
Yes, ma'am.
Okay. Now आपका फिफ्थ साइकिल, सो फिफ्थ साइकिल का हम इनपुट यहाँ पर रख देते हैं। ओ सिक्स्थ साइकिल आ गया ये 1 0 and the 1 will be taken at the output 6 and now this is the first output. So now this is 1 0. Next set of input is 1 0. So this 0 you need to push now. Next आपको क्या push करना है? 0. So you have to make the entry 0 here. This is 0. Now what is the content? I am writing the content over here. The content is 3 zeros, 0 0 0 and this is 1 and this is 0. So since last bit is 0, so all these will be actually 0 here, 0 here and 0 here. So 0 XOR with 0, what you will be getting? The content of this
0.
will become 0. 0 is get again you are getting 0. This is 0 XORed with 0. You will be getting the content of this is also 0. This 0 is getting pushed over here, so you will be getting 0. This is 1 and this is 0. So you will be getting 1 over here. And what is the output? This bit is going to the output. So this last bit is going to the output, which is 0 only. So you'll be having क्या हो गया आपका 0 0 0 0 1 and now the output is 0. Previous was 1, now this becomes 0. Okay, इसके बाद की यहाँ पर भी given है, so let's take it from here. So this was sixth cycle. In seventh cycle you are having these entries likewise, and at the end of eighth cycle you will be having this polynomial, and this is your output. Okay, so this output is nothing but the quotient and we will call this as remainder. इसको हम बोलेंगे remainder. And the same thing you can calculate in this way, that gx upon px is equal to qx और जो भी बचता है वो remainder आएगा. How will be calculating? एक बार मैं आपको बता देती हूँ करेंगे. So this is how you will be doing the signature analysis. So gx divided by px. What was px in this case? Px was x raised to power 5 raised to power 4 plus x square plus 1. And gx, how much was?
Ma'am, the
6.
screen is frozen.
Screen is not visible.
It is frozen, ma'am.
Screen is frozen. It's not going ahead.
No,
No, ma'am.
ma'am.
And your
Hello?
voice is also, I mean, your voice is cracking as well, ma'am.
Okay, let me check the connection. What you can see right now in the screen? What is visible? Please let me know.
Google Meet screen.
Google Meet
Now
screen.
we can see px, gx divided by px.
Okay. And this is also visible. Expression which I'm going to underline.
Yes, ma'am. Now it's visible.
Okay. So I'll be writing slowly so that it can be visible. So this was your gx and this is your px. So if you multiply this with x square, it means this can be divided well. So x square से multiply करके you will be having 7 x6 x4 x square. So when you will reduce it from here, this is x square times. This is getting cancelled. Okay. So this is how it is getting cancelled. And you are left with x raised to power 5 plus 1. X raised to power 5 is remaining, so once it can go. So plus 1 we will be doing. So you are left with, put it, plus 1 means you will be putting it like this, x square plus 1. So you are left with, this is getting cancelled and this. So you are left with x raised to power 4 plus x raised to power 2. So this is your remainder, right? And 1 plus x square is your quotient. Look at this, 1 plus x square, this is your quotient. दिख गया? Yes or no?
Yes, ma'am.
And the same thing we are doing with the help of this also. The same thing we are doing with the help of this also. ये actually x square आएगा. You are having LSB here and MSB here. So this is x raised to power 4, x raised to power 3 का coefficient 0 and this is x raised to power 2. So the remainder is x square plus x4. And the same thing we are getting from here. तो इसको थोड़ा correct कर लीजिए. You can see we are getting the same remainder polynomial over here. This is the remainder polynomial x4 plus x square and the quotient is 1 plus x square, which we are going to represent by qx. So this is how you will be doing the signature analysis using this clockwise output data and using your handheld calculations. You can do this. Okay. So this is x square. Please make a note of it. This is x square. So this is signature analysis. ये इसमें ये करके भी बता रखा है signature analysis. इसमें कुछ mistakes है. You can just have a look at this. So this is another type of multiple input signature register. Here you can see all the XOR gates are having different input sets, right? These are internal type LFSR only, but these are having different input sets. We will not call this as LFSR because the shifting is not happening linearly, but multiple inputs are available. In linear feedback shift registers, generally one input is there and all the shifting is happening sequentially through the XOR gates. But here it is not so. Multiple inputs are there for every XOR gate.
Ma'am,
हाँ बोलो.
ma'am, ma'am, in the quotient and in the reminder, the LSB was the on the left side or on the right side?
LSB आपका हमेशा लेफ्ट साइड रहेगा. एक बार आपको वापस से बता देती हूँ. When I started this, I told you. Look, this was our
Ma'am, क्या
GX.
wait हुई है?
Polynomial GX क्या था? This was our GX, right? Yes or no?
Yes, ma'am. Yes, ma'am.
तो इस GX को जब हम कैलकुलेशंस कर रहे थे, व्हाट वी डिड, वी जस्ट इन्वर्टेड दिस. हमने इसको 1 0 1 0 एंड 4 टाइम्स 1 ऐसे लिखा, बिकॉज दिस वाज द MSB. सो MSB इसका हमेशा राइट साइड में रहेगा. फॉर दिस ऑल्सो दिस इज द MSB, दिस इज योर MSB, एंड फ्रॉम हियर यू आर गोइंग टू स्टार्ट. ओके, एस बिट वाइज यहाँ से आप लिख रहे हैं, एंड द लास्ट वन इज MSB. So likewise, the MSB is the last one, whether it is the polynomial or the quotient. MSB आपका last one रहेगा. So in order to interpret this, this one is the MSB, means corresponding to x square, and this one is corresponding to 1. So 1 plus x square is the result. This one is corresponding to MSB. So total bits are 5. So MSB will be x raised to power 4 plus x raised to power 3 is 0. So this is x square. This is how you'll be writing this. ठीक है? X Raj, fine.
Yes, ma'am.
Okay. Any other doubt? So signature analysis, this is important, and we have learned this by two ways. First one is using the conventional shifting, and second one is using the mathematical expression. In the mathematical expression, what we are going to do, we will just keep on dividing the gx with the px in order to get the quotient qx over here, and remainder will be rx over here. This is the simple polynomial division which you have learned in your maybe 10th standard or 9th standard. ठीक है? So this is what we got. This is your px. This is your generator polynomial, which is we obtained from the input sets. This is fixed for one LFSR. This is depending on the inputs, and this quotient and remainder will also depend on inputs and input pattern, and remainder is also getting it on the basis of input pattern. So depending on the input pattern, you will be having a set of QX and RX. So depending on that, you will be analyzing whether this one is correct or not, means golden unit or not, error free or having the fault. This is what your objective was. समझ में आ गया? Yes,
Yes,
everyone.
ma'am.
Okay. So if you have any questions till now, you may ask. Otherwise, for today we are going to close. So I have seen multiple entries, multiple submissions in the assignment. जिनका रह गया है वो भी प्लीज जल्दी ही सबमिट करवा दें, क्योंकि 18th मैंने बोला था लास्ट डेट फर्स्ट असाइनमेंट के लिए. सेकंड को 2-3 दिन और डिले कर सकते हैं आप. ओके, सो इट इज लाइक दैट. फाइन. ओके,
Yes, ma'am.
सो
Ma'am,
इफ
could you, ma'am,
हाँ हाँ बोलो. Somebody
ma'am,
wants to ask something.
yeah, ma'am, I have a doubt in
अभी हाँ
assignment number one. Is there any
हाँ हाँ.
proper method? Is there any proper method for solving question number three in assignment number one?
Question number 3.
Yeah, ma'am.
Okay, just one. Somebody shared the question number 3 on WhatsApp as well. I was out of frustration. I couldn't check that actually. Classroom. क्लासरूम कौन चलाएगा? Where classroom? I'm not able to see. I think the net speed is really slow. Okay, this is not opening. I will get back to you later on because we need to be ready for the next class as well. So if it is not going to open now, I will be get back to you. Abhinav, fine.
Okay, ma'am. Okay.
Maybe in tomorrow's class I'll discuss that. Okay?
Okay, ma'am. Fine. Thank you.
Okay. Bye. ठीक है कल की क्लास में आई विल बी डिस्कसिंग दैट क्वेश्चन अभिनव अभी ओपन नहीं हो रहा है ठीक है
Okay, ma'am. Okay.
ओके एनी अदर क्वेरी डू यू हैव एनी क्वेरी सो फार